Hello everyone, welcome to today's webinar sponsored by RavenDB, the company behind the document-based NoSQL database platform, and InfoQ. My name is Srini Penchikala. I am the lead editor at InfoQ for the AI, ML, and data engineering community. I will be the moderator for this webinar. Today we are going to hear from Trevor Hunter from the Rakuten Kobo team. The presentation title is Kobo's Journey into High Performance and Reliable Document Databases. Let me introduce our presenter first. Trevor Hunter is the Chief Technology Officer at Rakuten Kobo, the company behind the popular ebooks, audiobooks, e-readers, and the tablet computers. Trevor leads the research and development organization at Kobo, where their mission is to deliver the best devices and the best services for the readers. Trevor, welcome to this webinar.
Thanks, Renee. Really appreciate it. I'm pretty excited to be here to talk about technology that I like, but also just the process we went through in exploring it and making our choice.
Sounds good. Thanks, Trevor. Yeah, let me go through some housekeeping items and we can start the presentation. For the background, quick background on the topic, we all know more than 10 years ago when NoSQL or non-relational database movement was just getting started. The first type of databases that were getting a lot of attention were the document NoSQL databases. We kind of know about a couple of databases that come to mind. Those were the foundation of the NoSQL database movement. At that time, storing JSON document either as text data or binary data was the kind of next big thing, right? When it came to data storage, and I know we have come a long way since then. But I kind of see document NoSQL databases as the foundation, at least for my NoSQL database learning. So these databases kind of revolutionized the data storage and management space by using innovative techniques for data sharding, data replication, cluster-based distributed database systems. So in today's webinar, we're going to hear more about this and learn about Kobo team's journey in adopting a NoSQL database for their application requirements, and what they went through, and finally how they arrived at using the RavenDB database. Before we go to the main presentation, I would like to go over a couple of housekeeping items. The main presentation will be about 30 minutes to 35 minutes long. After that, we'll have a 15 to 20 minutes Q&A where the presenter will respond to the questions from the audience. I'll be moderating the Q&A throughout the presentation. So if you have any questions during the talk, please post them in the questions tab. You should see the questions tab in the GoToWebinar control panel. During the presentation, everyone's microphones except the speakers will be muted. And this recording will be available for anybody who have signed up for this webinar but either not able to attend or would like to watch it again offline. You will be receiving an email with the details. So that's all for the housekeeping items. Trevor, I'm going to turn it over to you now, and I will turn off my video. Very much looking forward to the presentation. Please go ahead.
Okay, thank you. Hey, everybody. Thanks for taking time out of your day today to listen to me. It's probably not the most exciting thing you could do, but I'm going to try and make it at least interesting and useful to you. Looking forward to the Q&A after this. It's happy to dive in or talk about our experiences or what we're planning next with this technology. But for now, just a little bit of reintroduction for myself. I'm the CTO of Rakuten Kobo. I've been that for about 10 years, but I describe myself as curious. I love learning about a layer deeper in a technology or a process or something like that, and just exploring it and diving a little bit deeper. I think that, coupled with the amazing work that our team did during this evaluation, really helped us understand a level deeper than we normally would, and sort of led us to a better evaluation process through this. I'm very much driven by that curiosity to understand that layer deeper, or 2 layers deeper than just what the higher level API is. And hopefully I can give you a little bit of a glimpse to how that played out for us today. I also got 2 amazing kids that drive me, just to be better and better at this. Kyle on the one side with the blue shirt, he's learning how to program, and mostly in Roblox and Minecraft these days. And Damien loves playing the levels that Kyle creates. I am so very much going to teach him about document databases as one of the next modules, though. I've worked for Kobo for about 10 years, but shamefully admit that I was probably 3 years into it before I realized that Kobo is actually an anagram of book. We love books. Rather than endlessly doom scrolling at night, I am picking up whatever the next book is in my reading list. I'm currently reading Hail Mary by Andy Weir, the author of The Martian. It's got me riveted there, and I'm not checking feeds or things like that. I'm usually reading the book, and mostly science fiction side of it. At Kobo, we make devices that are frankly awesome in my mind. We've brought new technologies from the backlights to stylus to larger screens to thinner and longer battery life on these things. We measure battery life in weeks, not hours on these things. And it's sort of my pride and joy that I get to be a part of creating these things. We've recently brought in stylus into our devices, and that's kind of helped our focus with people reading nonfiction books, technical books or biographies, things that you don't generally read linearly, that you will pick pieces out, you'll do highlights. And that's actually the main focus of the use case behind this talk, is those annotations, whether it's highlights or notes or scribbles that you might make in the book. This is the use case behind this particular database technology. We, of course, have a very large e-commerce thing in 25 different countries around the world. We sell audiobooks as well as do our own self-publishing to enable authors to go directly to the audience. I love the diversity that's involved in our business, from the different countries we're in, to the different content types, to the different ways of consuming it, and being able to build systems in the background is pretty much the reason why we do it. But also really just to create moments like these. This is my son Damien just reading his book at night. I think he's reading The Iron Giant or The Iron Woman in this picture. And it's just one of those things that I love to see kids picking up. Behind all that is a very, let's say politically correctly, organically grown architecture over the 10 years that we've had. We've bolted pieces on, we have legacy pieces in one place, we have new pieces in another place. But it seems to work pretty well through a lot of our integrations and different data stores on it. This sometimes, though, is a bit of a Rube Goldberg machine. We have complexity built up where maybe it's a little bit of artificial complexity more than it needs to be. In one of the use cases, like the one that we're going to talk to today, we had a fairly simple system actually, but that led to a lot of complexity on top of it for our devices and our apps to read, and we wanted to simplify that as we went along. In terms of the data storage behind that architecture and enterprise systems, we've got everything I can think of at the moment. We've got a mixture of cloud services, we've got a mixture of relational databases, we have search engines like Solr and Elasticsearch. We have caches like Redis, and we use a lot of Memcache in it. So we're pretty diverse in terms of our data storage. We have an effort to consolidate some of this, but not aggressively so. We want to use the right tool for the right team in our organization as well too. But let's talk about document databases in this for a while. Now, by document database, I generally mean something that's going to support independent services, whether that's microservices or an isolated system. It's going to use JSON as its storage or persistence format and the way it serializes objects. And it's generally not shared between multiple applications. It's not like a relational database where multiple applications will be talking to it and it'll be recording the financial transactions. This is generally an isolated database for a specific service or an application, although it might publish events or ETL to other databases in the background, but generally there's one application, obviously many instances of that application, reading and writing to that database. Personally, I find this the right model to use simply because there's very little translation there. There's no ORM in between where there's mappings and things like that. That being said, I don't think that there's such a thing as schemaless. I think there's schema now, which is upfront design. Every row conforms to what the schema is you define upfront, or there's schema later. The documents don't adhere to it at storage time, but your queries kind of expect some kind of schema there, but are flexible enough to work when the schema doesn't exactly match that. So I refer to the storage time schema or query time schema that we're doing. So document databases for me very much lie in the schema later aspect of it. So one of the things that we do when we're evaluating technology is get our requirements right, or get our desires right, what we're looking for from that technology. So pretty much if you're in the data storage area, you are going to look for it being reliable. You don't want data loss. And reliability, you also want pretty much good uptime. You also want it to be performant. You want queries to come back pretty fast. You want it to scale with the number of writes that you make. But you also want it to be efficient. You don't want it to be wasteful of resources with requiring a lot of RAM or CPUs to just be that performant and reliable side of it. But we also want a great developer experience. We want to move fast with our development teams. And for me, that means very good ability to debug what you're doing, very good ability to run tests against what you're doing, a seamless and fast developer cycle, and a really, really good safe by default experience for the developers. But from operating it in production, you also want that ability to monitor, to introspect, to debug, to see why things are not optimal in that. So we want a great developer and a great operations experience on this. In theory, what we had previously was SQL, a relational database, with a memcache in front of it for the performance. That allowed us to scale in the early days of Kobo. Now I'm talking 2008, 2009 era, so well over 10, 12 years ago on that. What we thought we could do back at the time, which is about 2012, 2013, is we could kind of replace that with Couchbase. Now, Couchbase being essentially a distributed database, storing JSON-like documents, we thought we could start using it as a system of record, not just a cache. And also the API would be very similar to what we had already used in our application, basically the memcached interface. So we thought we could migrate to that, achieve a little bit more scale, and achieve reliability and system of record out of it. But we failed with that. We never really could get high availability working with that distributed database, despite there being multiple replicas of things. We never really could get disaster recovery working the way we wanted, whether that was a separate environment that's always up to date with streaming data, or even just simple things like consistent backups. We ended up using way more resources than we thought, and performance wasn't really where we wanted it to be either, despite all the resources that we threw it. And the developer experience was a little bit fraught with issues, from upgrading client libraries to not being safe by default in a lot of the things. And operations really didn't like it at all. From not being able to do backups, not being able to see it, and the amount of resources it was using on our on-premise infrastructure. Now, I will caveat that we probably did things wrong as well. We made some mistakes in our architecture. We made some invalid assumptions, but at the same time too, it was kind of easy to make those invalid assumptions. It wasn't necessarily the safe by default. It didn't necessarily lead us into the pit of success with this. Speaking a little bit about a specific use case rather than general technology and our experience with it, I'm going to talk about annotations. Now, an annotation and domain language for us is anything that's a user puts into the book on top of the actual content itself. It's like your notes, your highlights, whether you mark a specific page to come back later, or even markups, your handwriting or extra diagrams that you might draw on with the stylus. This is essentially the use case where you do it on a device or inside your application, and it synchronizes back up to our service, so that's available across all your devices, or if you log back in and out again. We don't share these between users or make any public notes or things like that. It's just purely as a way to back up your own notes on it. What we started with on this use case back in 2009 was Azure table storage. And it grew for about, I would say, 8 or 9 years on top of that, up to about 1 billion records in there. So fairly sizable database, not crazy massive, but fairly sizable. But its access patterns that we initially implemented on it weren't really scaling very well, and our timeouts and errors on top of the API were fairly good or fairly bad. And we felt like we were wasting a lot of resources, certainly wasting a lot of dollars on the storage, and we thought we could do it better internally. At the time, which was about 2018, 2019, so going up on 5 years ago, geez, time flies, we decided that our incumbent thing that we had run for many years, we'd try and put it on Couchbase. We tried to do a lift and shift, and then we tried to optimize it essentially. But we hit many, many walls. Essentially, we hit the wall of performance, we hit the wall of reliability, with the wall of not being able to do disaster recovery very easy. And as soon as we started stress testing the new API service, we just were not comfortable with the switch from the cloud to on-premise for that. So really felt that we had sort of dived into the lava pit of failure rather than a pit of success with this. So what do? We started exploring alternative technologies. And 2 contenders we considered at the time was MongoDB and RavenDB, both fairly mature document databases by that stage, which was again 2018, 2019 era. And we decided to implement this use case on all 3 backends, databases, and compare our experience with them. That's what I'm going to talk about now. A little bit of a side note before I get that. I really think that if you're evaluating technology or a system in general, you really should take a look at exploratory testing. It really is about trying different things, learning about what you observe, and applying that learning to generate more tests and questions. It really takes what's a black box and allows you to turn it into a white box without really deeply understanding it. And it's such a fun way to test as well too, because you're testing and learning at the same time. And it allows you to put hypotheses forward and test those hypotheses. And just like in science, it's great when your hypothesis is wrong because you learn something new in that rather than just basing on your assumptions. Highly recommend this way of testing, especially when evaluating new technologies. So how we get into that, let's take a sidebar on the differences in internal architecture between these systems. Couchbase is very much a distributed, sharded database. Each node holds part of the data. No one node generally holds all the data. You've got 3 different servers and 3 different failure domains, but with the replication factor, maybe 2 out of those 3 nodes have the same item, but no one node has all of them. So it's a truly distributed database. My assumption on that was it was in the days where storage available on each node wasn't very big, so you could do a very large database over multiple nodes. It has implications in terms of being able to query across those nodes, certainly in terms of performance, but ultimately no one node has a complete view of the database. However, MongoDB and RavenDB, if you set their sharding capabilities aside, by default every single node has all the data on it. And this came about with the increase in storage size available on each server. So you're able to store multiple terabytes on an individual node now. So both MongoDB and RavenDB essentially have each node with a full ability to query the whole database. And you're replicating for reliability and load sharing on that. Mongo, though, is very much a primary-secondary architecture, where one node is generally the one accepting the writes, and you can use the other nodes for eventual consistency on your reads. One of the nodes fails, generally another one is elected the primary, and clients will switch over to that. So it's very much a primary-secondary traditional thing. Whereas RavenDB is very much a primary setup. It's each node, again, has the complete copy of the data, but all nodes are equal. You can read and write to any node, and it'll be replicated to the other nodes. When a node goes offline, whether it fails or there's maintenance involved, there's nothing to do. There's a background cluster leadership, but it doesn't affect any of your database availability or writing. It's master or primary secondary versus primary in some of this. It's important to keep this in mind as a layer deeper in the internal design of their architectures. So what we did in terms of our test plan, performance is obviously part of that. So we tested how long it takes to actually import the data from Azure into the actual database. Now, I'd assume reading from Azure across the internet into our data center would have been the actual bottleneck there, but no, the actual database itself made a very big difference, and that really tested its ability to write use multiple threads and basically ingest the data as fast as possible. Our second test, again, focused on performance and latency. So we ran our application, basically synchronizing, reading and writing annotations using load tests with traditional set up a test in JMeter or something like that and compare the different backends and our application performance on that. The third type of test is my favorite. It's the chaos monkey type of test. We yank nodes out, we forcefully turn them off under load, and we watch what happens. We even ran things with low memory on the node. We ran things with slow I/O just to see what would happen and to learn a little bit more about degraded mode in each of these systems. And it's fun coming up with these test scenarios, and it's really fun diving under the skin of each of them just to see how they react to these less than ideal circumstances. And then finally, keeping track of our experience, the developer experience, how easy it was to develop against them, how easy it was to set up, how easy it was to do backups, and also evaluate the companies behind them. How willing were they to support us when we had problems or questions, as well as the general cost of licensing or support costs or things like that. Our actual test architecture. So now I'm talking about the specific load tests. We had JMeter tests running in BlazeMeter out there, which are reading and writing to HTTP API, which is running Kubernetes with 8 instances on it. And then we basically had different backends behind that API that we could write to based on whatever test we're running. So in Couchbase, we had essentially 7 nodes, which were 8 cores, 96 gigs of RAM, SSD backed. And for MongoDB and RavenDB, we actually had a lot less resources. We had 3 nodes, 4 cores, 36 gigs RAMs each, and the backing store that was the storage attached network. So it wasn't direct SSD like Couchbase was. And so we automatically out of the gate had a bit of a handicap on MongoDB and RavenDB as we ran some of these load tests. The use cases there, we add a new annotation, which is a write operation. We'd retrieve annotations for a given user in a given book. We try and retrieve annotations for a book that doesn't exist, just testing, the null use case. And then we'd delete an annotation. So it's a little bit of a mixture of read and write, typical, probably 10 times as much reading as we were doing writing in this. And then we'd measure things like latency and resource usage on each of them. So what we found on that, our first test, remember this was importing from our system of record in the cloud. It's about 400 million documents at the time, or about 150 gig in size, not massive, but doing that over the internet, row at a time with many threads on one machine, the very big difference in the write performance of that. Now bear in mind the different resources available to this. Couchbase, we find it very, very slow to do the right performance on it. And we probably could have increased that, but I don't think we could have got it down from 7 days to essentially 1.5 day like we did with Mongo and RavenDB. Our second test, the load tests, Couchbase, we topped out at about 170 requests per second with a 200 millisecond response time. And that's not acceptable for a modern day service that's returning a small piece of JSON. Both MongoDB and RavenDB basically came back equal in terms of performance. Well over 1,000 requests per second, less than 10 milliseconds latency. And that, bear in mind, that's end-to-end time through our application, not just the database access time. Chaos Monkey, basically when we started pulling things apart and seeing how they behaved, Couchbase did what we kind of expected it to do, and didn't really hold up when we pulled one of the nodes out of the cluster. It had to rebalance the data across the cluster, and that rebalancing operation led to essentially 2 hours of downtime when one of the third nodes fails. MongoDB, insignificant downtime, maybe a few seconds when it switched over to one of the secondaries, but RavenDB came out better, 0 downtime. A few errors when writes, which we expect because transactions would fail in the middle of a write, but retry would work immediately on one of the different nodes. So we're very impressed with that. But it was insignificant on the Mongo side as well. And then test 4, keeping track of other things. Couchbase, the dev experience was okay. It was a pretty simple API that we're using, just a put in the get. We weren't using any complex queries. Operations experience, from the downtime to rebalancing to the resource usage, and then the very costly commercial support that went with it. Mongo, we ran into some gotchas with the dev experience. The atomic writes weren't out of the box by default in the client libraries. The operations experience was kind of disjointed, having to use multiple tools to monitor it, to set it up, to configure it, whether it's command line or the more enterprisey type tools around that. And again, the commercial support we find very costly on that. RavenDB, great developer experience, which I'll talk a little bit later about why. Operations experience was great with no downtime, very easy to set up backups, very easy to set up disaster recovery replication, and the cost we find pretty reasonable in terms of both its licensing and its support cost side of it. Diving a little bit deeper into some of the tests, here's a bit of a graph of RavenDB. Now I'm going to concentrate on RavenDB versus Couchbase here, not RavenDB versus Mongo, because they're kind of equal on that. And the experience was a differentiator on that. So what you see here in the top graph is essentially the amount of load that I was able to sustain using the graph. So RavenDB, pretty much 5 times. That's the request per second, given the number of users, which is the blue line. So as the blue line goes up, the number of users go up. It's pretty stable in terms of the amount of requests per second it was doing. Whereas Couchbase pretty much flatlined at a low number of parallel users that we could get through it. In terms of the response time, again, lower is better in the bottom graph. As the number of users went up, RavenDB's response time marginally went up, but not massively. But Couchbase basically scaled linearly its response time up to 2 seconds as the number of parallel users. So it didn't scale at all in terms of parallel requests that we did on it. Also, when you're running systems, is variability of response time. It's not just about response time being good, it's about response time being consistently good. And RavenDB, no matter how many users we threw at it, and over time, it remained pretty much flat, well under our target for that. Whereas Couchbase was kind of up and down all over the place as various different background and operations happened. When we got to chaos testing, this is what we observed. What you see is we pulled the plug at 1532 on one of the RavenDB nodes, and the errors that you see there are writes that were in progress. Rightfully, it failed the transaction. The application reported a transient error for those writes, but pretty much recovered right away, no issue from that. When we killed a node on Couchbase, nothing happened to the data. We didn't experience any data loss or unavailability of the cluster, but the background rebalancing operation, again, remember Couchbase is a distributed database. And when you remove a node, it has to rebalance the data across the remaining nodes so that it retains its availability and redundancy of that data. That rebalancing operation internal to the cluster itself took about 2 hours. And during that time, we just saw timeout after timeout because the background operation was much heavier than it should have been. When we talk about resource usage, remember RavenDB and MongoDB were using 3 nodes, 4 cores, 36 gig RAM each, not a very big server at all. Whereas Couchbase was using 7 nodes with 8 cores each, 96 gigs RAM, much more powerful cluster overall. But we were able to achieve much more throughput and response times on the RavenDB side of it versus on the Couchbase side. And when you actually look at the resource usage, now what the graph below is our application usage, not the database CPU usage. The first part from 1535 to 1550 was when we were running RavenDB. Our application was the bottleneck. Our application with its 8 nodes was using almost all of its CPU at the time to serve the requests. We could have scaled that out with more instances on it pretty easily because it's stateless. But on the Couchbase one, which is number 2, from the 1550 to 1605, the resource usage on our application side was very low, showing that our application is not the bottleneck in that case. It's very much the backend database of it. During that same time, RavenDB was only using about 25 to 40% of its CPU on one of the nodes that was serving most of the requests. Whereas Couchbase under loads on the actual database nodes, 90% of those 8 cores were being used across pretty much all the cluster. So not only Couchbase had more resources, it was using a lot more resources than RavenDB during that time. And given RavenDB's ability to run on things like low power Raspberry Pis and things like that, this became all more important to us when we scale up that to larger servers, is that efficiency of the resources that it used. So ultimately, it's no surprise, our decision was with RavenDB. I was driven mostly over MongoDB because we thought it was safer by default. The APIs were a little bit more guided and easier to use and fall into the pit of success. It was a very targeted use case over the large feature set that we got out. And the ability to see what's going on inside the server was excellent. And we got really great support and response from the team behind RavenDB. So we made the choice going with that. So that was our test methodology. If you have questions on that a little bit later, there's actually a white paper on this specific use case created with publicly available data from Stack or various different sources that recreates what we did internally. If you want to give that a go yourself and try it. Again, this was 4 to 5 years ago that we made this decision. So various products have improved a lot since then. You might get a different experience, but we are very happy with our experience, mostly on the resource usage and performance and operations experience, but also just on the dev experience as well too. That said, change is hard. Adoption of a new technology, no matter how good it is, takes time, takes learning, takes what you learned during that exploratory testing thing, takes a lot of that to get over to that. Developers, as progressive as they think they are, they don't really like change, and it takes a monumental effort to actually get an organization to change to new technology. But there's a lot of good things out there that we did to help with that. First of all, read the manual. This book is great, not just about RavenDB. It's great about distributed systems in general and what generally goes on behind the scenes, as well as application design. There's a lot of, I think this probably should be required reading along with clean code and domain-driven design and various other books out there. But this book on RavenDB is worthwhile beyond just the product itself. There were some frictions. No technology is perfect, but some of those frictions were actually good for us. The push to use TLS or HTTPS as default forced us to get better at our certificate management inside our enterprise, and helps us get a step closer to that zero trust or defense in depth type of approach to our internal networks. So that friction of setting up the certificates and rotating them all the time was actually a good thing for us to get better at. But there's a very big gap between being good, which is the out of the box and using it for defaults, and being great, and that takes time and dedication to get through. You have to optimize, you have to observe. And one of the things that I'm a very big advocate for is this idea of a full stack database administrator. This is not your typical DBA that works only in a database. This is somebody on the team that understands the data and access patterns, how the API or applications using it, knows the data lifecycle, when things should be deleted, when they're no longer useful, when things should be aggregated and the source deleted. They're constantly profiling and fine-tuning, whether it's looking at indexes or not using an index and using document IDs as natural domain keys and things like that. Looking at how to pack the data a little bit better and gain more efficiency for large databases. And also looking at the caching strategy. This is, to me, this full stack DBA is not just about the database, it's about the application and how it uses that data. And that ability to constantly improve and fine tune things is really important with any technology. But for RavenDB, it brought us from good to great in some of our use cases. Some of the not out of the box optimizations that we did through acting like a full stack DBA is things like GUIDs or universal IDs. We use those a lot in our enterprise, from product IDs to user IDs to various entity IDs. And by default, you'll store those as strings. But if you base64 encodes the actual raw 128 bits behind that, you can get about a 30% saving on the raw daily size. Now, that's in a database where there's a lot of GUIDs that reference other products and other systems, but a 30% saving without compression or anything like that, just by encoding the data a little bit differently, helped us with one of our larger databases quite significantly. And that's something we do on the application side, not the database side. Natural or domain keys, as they're called, should be used a lot more. In RavenDB or other document databases, document IDs are generally an O1 lookup. They're not subject to indexing. In RavenDB, they're also atomically consistent with the rights. So if you can structure your document ID around how you're going to access that, you can gain a lot of efficiency in both performance, but also not having to use extra storage for indexes and things like that. The example here, our typical access pattern as a user is getting the list of annotations for a specific book. So we have the user ID, we have the ID of the book that they're looking it up for, and we can very efficiently, without an index or anything like that, list the documents that are listed there. So it really allows that efficient lookup for those common tasks without that secondary index. And then finally, if you look at your API side, caching and conditional gets are very, very important. And it's not just important to shed load off your server, like you don't have to do that. Like returning a few hundred bytes of JSON versus not returning a JSON isn't that big of a deal in the grand scheme of things. But when you have billions of requests a day, it can make a difference. And it can also make a difference on the client side. I mentioned earlier our e-readers with weeks-long battery life. Well, if we don't have to parse the JSON when it synchronizes a response, that's a lot less CPU usage that we get, because those devices achieve that weeks-long battery life by being off 99% of the time. The CPU's spun down. If we don't have to parse the JSON in a response, that's actually a significant battery saving as well on the client side. So these are the kind of things that I very much advocate somebody with an interest in data and an interest in data access patterns should take a role of a full stack DBA on the team owning that service. Some of the pleasant surprises in RavenDB since we adopted it, upgrading is a non-issue. With Couchbase, to try and upgrade a node, we'd have to take it out of service, which would cause the rebalancing thing, which basically meant that we never upgraded the version of Couchbase in our environment, which was bad for us and probably led to some of the problems that we see. For RavenDB, because it fails over very gracefully with no errors, we just simply shut down a node, replace the binaries, restart it, and it's up and running in about 30 seconds. We've automated that. We can download the latest updates, deploy it to all of our nodes in probably a few minutes. So as a result of this, we're pretty much always on the latest version of RavenDB, and that's a good feeling to have, because we have run into issues, we have run into bugs. The team's been very good at providing bug fixes in the next release, which I think generally are monthly, and we've been able to keep up with that without any downtime. It's been a very pleasant surprise. The studio, I mentioned one of the reasons with MongoDB was a sort of disjointed set of tooling that you use to manage it. The studio that's built into RavenDB is fantastic. It can give you the overview, high level. It can give you details of what clients and what queries they're actually running in real time with a traffic watch, or can dive down and show you your IO usage on the server to see if there's an IO bottleneck on it. Everything from doing debug logs to traffic watches to observing in the cluster is available here. And it's also backed by APIs that you can build into it. Another thing which was great, there's a lot of debug and admin APIs available from each node in it. And in the early days, we were very easy to integrate that with our monitoring stack, which was Telegraph and Grafana, building our own dashboards to watch CPU usage, request durations, requests per second, disk IO, memory usage, things like that. We were able to build very detailed diagrams that would show us a lot of insight into it in our own system. There's an official Grafana plugin, there's an official Telegraph plugin based on some of our work on this that sort of implements beyond the studio into your existing monitoring stack on it. The developer experience. Full stack unit tests to me are a game changer in the way the dev lifecycle works. What this is showing is running a unit test suite and debugging it in real time using the local embedded studio, which is a full RavenDB server running locally. No setup, no nothing like that. It just runs as part of your unit tests. It's fast enough to run as unit tests, not integration tests. And the idea of the full stack unit test there is I'm not just testing my API service, I'm testing everything down to the serialization of the database, the indexes that run in the database. So now I'm running unit tests against indexes in my database, which is fantastic. And it runs fast. It runs fast enough to run as a unit test on that local machine. So I have much greater exercise and test coverage of my tests. And the debugging experience, as you can see here, I can launch into the local studio by setting a breakpoint in the tests and go in and modify and edit the data to see why the test is failing and things like that. This is a very pleasant surprise in the RavenDB test driver and how we do it. Another pleasant surprise was simplified asynchronous workflows. You can have a subscription on RavenDB that subscribes to changes in documents. So what we actually implemented was, instead of using a queue like Kafka or RabbitMQ, we actually implemented our full purchasing system, which is a set of asynchronous workflows, by watching the state of some documents. And that allowed us to simplify our infrastructure and allowed us to actually, during debug time, step in and see the state of various asynchronous workflows on it. So when an order comes in, writes a document, which kicks off a price check, which kicks off a fraud check, which kicks off a capture payment, and kicks off a fulfill order asynchronous workflow. And they all write back to the various documents that support that workflow. And then we ETL it out to our financial reporting SQL database. So this allowed us to simplify essentially a very complex purchasing workflow on it. But in that, we did overload the Studio UI quite a bit with our excessive subscriptions and documents. We'll probably clean this up a little bit later, but just one of those funny little bits that, you know, when customers start using the product in ways that you didn't expect, it happens as well. Some of the things we're looking forward to, one of them is, you know, queues and outboxes, sort of taking that asynchronous pattern a little bit further. If you're familiar with the outbox pattern, on one side here, we've got an API that writes to the domain layer, that saves something to DB and then publishes an event. Trouble with that is your applications now depend on two pieces of infrastructure, your database and your outgoing queue, and it's not atomic. I can't write to the database and write to the queue without using some kind of complex distributed transaction or compensation pattern to publish the event at the same time I'm writing to the database. And ultimately, your application API is only as available as the multiplication of the availability of your database and your queue. So 99% reliability, and the 99% reliability is actually 98% reliability for your API. And in our experience, we've actually had quite a few issues with our RabbitMQ infrastructure in terms of its high availability that have actually brought down our API, whereas our databases, whether that's Raven or SQL, have been very highly available and reliable. So what I'm looking forward to is the ability in RavenDB, which has actually launched since I did this presentation, is the ability to just write to the database. You save your state to the database and save a transient document in the same database, in the same ACID transaction in the database, and have the database ETL that out to a queue as a separate process. So now your application only depends on one piece of infrastructure. It's atomic in terms of publishing the events, and your ETL can be reliable, like your queue infrastructure could go down, and it'll pick up where the subscription goes. I'm really looking forward to this because it'll simplify the dependency of our application quite a bit. So in summary, make the developer experience and operations experience a priority. If you're evaluating technologies, experience matters, not just the performance, not just any technical metric about it, but your experience matters. And we certainly find that with RavenDB, from the dev experience, the safe by default, to the ability of full stack unit tests as part of our things, to the very easy way to set up a new cluster, add and remove nodes to a cluster, to set up replication to another thing. Also, to be efficient as well as performant, the resource usage is as important. To invest heavily in your evangelism during rollout, and train some of your team to be full stack DBAs, to go from good to great. Also, simplify your app and infrastructure as well, like reduce the amount of dependencies your app has from database and queue to just database alone. That can really help your reliability and simplicity of what you have. That's all I've got at the minute, but there's much more detail behind the scenes. I'm hoping for some really good interaction and questions during this. I will caveat though, your mileage may vary, and your mileage will vary. Products have evolved since we originally did this evaluation, but we are very happy with the decision we made and the pleasant surprises that came beyond that. We're looking forward to some of the new features, like I said, the ETLs to the queues, the new query engine, sharding support that's coming up for our larger databases, and also sharding from a customer privacy and data residency perspective is really interesting from that. So thank you for taking the time to listen. Really appreciate that. And we'll open up the floor to questions now, Messina, if you want.
Yeah. Hey, thanks, Trevor, for the great presentation. So yeah, just want to quickly mention that regarding the white paper, if you see in the chat section, David actually shared the link to the benchmark, performance benchmark, right? So please check out that link. And yeah, and also please, if you have any other questions, please go ahead and post them in the questions tab. We do have a couple of questions. Trevor, maybe we can quickly go over those.
Sure, yeah.
Okay. The first question is from Vishesh. He's asking about the annotations. The question is, if the number of annotations are huge in a book, then isn't loading all of them a high latency call? How do you kind of, lazy loading versus eager loading? How do you kind of balance that?
Yeah. So it was actually a little bit of a debate that we had at the start. First of all, I'll refer back to full stack DBA. You need somebody that understands the shape and the usage of the data. So we did a bit of research. We looked at our data, our existing data, and looked at how many annotations were typical in a book. Like, we got to know our use case. And yes, we had an edge case. It was either caused by a bug or something like that, where we had about 10,000 annotations in a book, which was our extreme max case. But we also noticed that most books have 7 or 8 annotations in it. So the 99.99999 use case was less than 10 annotations in a book. But our internal architecture debate was, do we store annotations for a book as one document, or do we have multiple documents, one for each annotation in the book? Ultimately, we ended up deciding on multiple documents. So our document ID is user ID, book ID, annotation ID, and we load those individually. And our API design essentially pages those out with a maximum of 250 each time. So it's extremely unlikely, like the 0.0001 case, that you'll ever have to get a second page of annotations from our API. But because we use that natural domain key of it, it's very, very cheap operation to get a page of annotations from the database. We're not using a secondary index to look up those things. But even if we did decide to store all annotations as a single document, I wouldn't be concerned about the size of that document, because we actually spent the time to look at how our users are using their data. Now, I realize when you're writing a new service, you have no existing data to go on. We were lucky we were importing an existing data set, and we could do that analysis and introspection on the usage of it. But it's an important lesson for optimizing your service over time and continuous refactoring. Hope that answers the question.
Thanks, Trevor. Yep. The second one is Alexandra has probably a few questions, I guess, bundled into one question. So they're wondering, any figures, like what are the kind of some metrics about, you mentioned about exploratory testing, training, integration in your application, and rollout. Yeah, I think these are probably 4 different questions, but yeah, can you share any experiences on these? The first one is exploratory testing.
So on the exploratory testing side of things, it is really just an iterative process of learning. You make some assumptions, you write those assumptions down, you design some tests around it, and then you observe various aspects of the system when we did that. So we probably spent, I'd say, 2 weeks in that kind of mode, evaluating the different projects on it or products on it. And, part of that is just iteration, how many iterations you want to do on that. We started with the import process, and then we did the load test, and then we did the chaos tests on it. But what's important is that you write your assumptions, you validate those assumptions, and hopefully some of your assumptions fail, so you learn something about the internals of it. But what's also important is that you have multiple people watching the execution of the tests. Somebody might notice something weird in the CPU usage. Somebody might notice something weird in the logs. Somebody might notice something that piques their interest. What's important is that you have a lot of observers during the running of the tests.
Thank you. And how about probably maybe rollout is the second sub question we can take out that any kind of experience on the rollouts of your app, the database?
So the rollout was actually pretty smooth. Our application, that our use case that we talked about, specifically focused on annotations. We imported database, we ran our load tests on it, and then we got into the standard thing. Well, how do we switch clients over to the new API and things like that? So it was drawn out over a few months, not because it was hard to do, but because we wanted to be responsible and incremental in how we did it. But setting up a new cluster was a fairly trivial task. Our architecture actually has our production cluster with 3 nodes, a disaster recovery cluster in a different data center across the ocean with live replication going between it, and then backups running all the time from the disaster recovery cluster. And that was pretty trivial to set up and get right. Most of the time actually spent doing automation, how to upgrade the cluster and things like that, or figuring out how to improve our certificate management practices for the HTTPS side of it. Since then, we've rolled out probably 20 different databases and services on RavenDB. So that initial first one was a large data set. Like I mentioned, we rolled out purchasing, we rolled out shopping cart, we rolled out wish list, we rolled out various other e-commerce functions on it. Those are trivial to add a new database, add a new environment for in the dev environment. And because there's no ORM or things like that, developing against it was very good, very easy. And we don't generally get into complex use cases with a lot of those. Some of them we did, like the asynchronous side of things, took a lot of time for us to figure out the right patterns to use. We actually advocated for parallel subscriptions in the feature set, which the RavenDB team delivered for us. And that was probably the most complex thing that we've done so far on it, to use those asynchronous workflows.
Right. As you mentioned, the data lifecycle, and I would even add application lifecycle. We have to look at the big picture to make sure that we are kind of addressing all the concerns, right? So,
yeah.
Yep. So the next question, more of a comment, I guess, from Glenn. Yeah, he wants to. He's thanking you. So, thanks, Glenn.
Thanks, man.
And then last question from Vishesh again. Let me kind of read this first, and okay, I'll just read as is. So, do we have any access pattern which says how many users have marked a certain annotation? Let's say some good line in a book, and many users have marked it as an annotation. So access pattern is how famous annotation is. So is there any way kind of to easily query the annotations that a lot of users have marked?
So we don't do at the moment analytics across users. Each user's generated content is theirs, and we don't share that across across users. And we find that people's notes are kind of private to themselves.
Exactly.
So respect that. If we were to do that, it would be relatively easy in RavenDB because each annotation has the ID of the book, and it also stores a location marker of where it is in the book. So you could do a little bit of index design to do a count of by location and things. And with RavenDB's map reduce, it'll take a little while to do the map and reduce, but after that, it'll be relatively fast to query on it.
Okay, thanks, Trevor. Yeah, we're almost out of the time. So, and I don't see any other questions, but if anybody have any questions, please reach out to David. Actually posted the email ID. So please reach out to the team and our InfoQ team as well if you have any other questions offline. But we're almost out of time here, so let's kind of wrap it up. Thanks, Trevor, again for an excellent presentation. I mean, this is a presentation about not just a product, but more of about the patterns, the lessons learned, different architectural considerations the developers should look into, right? So, do you have any final wrap up? Any comments to wrap up before we close the webinar?
No, like I said, your mileage may vary. The process of exploratory testing is super important and actually a really fun experience to do. And then continuous improvement. Like, don't just deploy the technology and go. Make sure you go from good to great with actually being curious about it. Like I said at the start.
Yeah, definitely. I think there will be more miles after the production implementation than before that, right? So before the implementation.
Yes.
Yeah, cool. I think that's all the time we had. Thanks, Trevor, again. Thanks everybody for joining this webinar. Again, this is mainly for the community. The attendees, we do this webinar for you guys. So we want to share what's happening in the software development world with you all. I hope you got some value out of this. Thanks everybody. Thanks, Trevor. That's all for today. See you next time.
Thanks very much. Take care.